right, let's do this. Big day for you guys here. Big honors level day. First thing I just want to review real quick. I got circle O up on the board to your left. What type of angle am I looking at there? That's what I'm going to ask somebody first. Angle ABC. We dedicated a whole day to this type of angle. A lot of questions on the quiz Friday, Monday about it. What type of angle is ABC there for circle O? Here we go. Start us off right. Look it up if you have to. Caroline, you know what type of angle we're working with?
Is it inscribed?
That is inscribed, correct. The vertex is on the circle, and the other two sides are chords. Perfect. This is an inscribed angle. What about circle A now? What type of angle is CAT? This is going back to, I think, day 2. CAT, 15. Will, what type of angle am I working with CAT?
Central
That's
angle.
a central. Nice job. Okay, so we have talked inscribed. We have talked central. There's one more angle found inside the circle that we need to talk about. And it is where the vertex is not on the circle. It's not on the center. It's just kind of floating in the circle. Okay, the vertex is just kind of floating in the circle. And since it's floating, I call this angle a floater angle. That's just, is it an official name? No, that's my name I give to it. It's an angle formed by two chords. It has no official name, so a couple of years ago, I just started calling it a floater angle. Do you guys see here? I have 4 floater angles there that are formed. Okay, because the vertex is not on the center and it's not on the circle. All right, so here's today's big topic. Only theorem I'm going to give you is how to find the measure of a floater angle. This one's a little bit more involved than how do you find inscribed again? How do you find an inscribed angle? Take half its arc, and then what about the central? Equal to its arc. Now for a floater angle, you're going to take half of its intercepted arc. So whatever arc belongs to the floater angle, so I'm going to say its intercepted arc plus add to it its vertical angles intercepted arc. Okay, so you're going to take the arc formed by the floater angle, add it to its vertical angles arc, and then cut it in half. Let me show you exactly what I mean by using a floater angle on our diagram above. All right, I need a favor from somebody, please. A little favor. 2-6. Emma, need a favor from you. Can you just give me one of those 4 floater angles, please?
ACB.
Okay, you got it. So everyone ready? ACB. How would I find the measure of ACB, which is referred to as a floater angle? I would take 1/2. What arc is formed by angle ACB? What arc is formed by angle ACB right here? What arc is formed? Arc AB. So I would take arc AB, add it to, now look at the vertical angle for ACB and name its arc. The vertical angles to ACB, and what arc is formed by that one? Arc DE. So I would take AB plus DE and cut it in half. That's how I would find floater angle ACB. Okay, everyone all right? Just wanted to show you using an actual diagram. And that's it. That's all I'm going to give you today. That's your last angle that can be formed inside a circle. So let's try out a couple basics, and then we go right to hardcore ones. X is not the center, by the way. That is not a center point. Those are just 2 chords right there. They do not go through the center. So angle X, it's not central, because I told you it wasn't the center. It's not inscribed. It's a floater angle. So how do I find angle X? I take half of its arc that it forms, 88, and then add that to its vertical angles arc, 86. What are you doing with your calculators. What are we doing? Honors kids, you get an 88 on one test, you get an 86 on the other test. What's your average? We all good? Put those calculators away. Oh, I love doing that every year. I look forward to that. What are you doing with your calculators? What's half in between 88 and 86? So that's 87 degrees. Now on number 2, I gave you the floater angle now. Now you know the value of the floater angle. It's 65. So now I'll start this off by saying the floater angle, 65, is equal to half. What arc belongs to 65 degrees? 100, plus the vertical angles arc, which we labeled x. I'm just kind of interested. What are you doing from here, algebraically? Because there's a couple things you could do.
Multiply both sides by 2.
Okay, if you want to get rid of the 1/2, which I prefer, you can multiply both sides by 2, or you could take the 1/2 and distribute. It's up to you. I prefer not to work with 1/2 x. I don't know, that just scares me sometimes. So I'll take Quincy's suggestion and get rid of the 1/2 first by multiplying both sides by 2. You don't have to. You guys want to distribute 1/2? Go ahead. Maeve, what's up?
It's so say it's vertical angle is 115. How come it's not like would it be the same like because you're just doing x plus 100 again? Like would it not be the same answer?
Say that again.
If we do like 100 plus x, we could do that for both like times 1/2. We could do that for both 65 and its vertical angle, which is 115, right?
Why would no, the vertical angles are equal. If that's remember, vertical angles are equal, so if that's 65, that's got to be 65. Okay? All right, so we got, what do we have, $1.30?
But that's because the angles are converted to arcs and then you convert.
That's only a central angle, right? That only works for a central angle, that it's equal to its arc measure. All right, good. You guys are starting to see a little facts here. Move the 130, move the 100 over, 30 equals x. Everyone all good? Basic ones right here, floater angles. Inside, so you have 3 types of angles inside a circle. Central, inscribed, and now floater. Those are the only 3 you could have that are located completely inside the circle. All right, let's get a little bit more challenging. What do you say? AD is a diameter, got it. Ooh, numbers in a ratio, arcs in a ratio. What's the value of angle x? Hey guys, what have we been doing all year when I have numbers in a ratio so I can write equations? Because I can't do anything with the numbers by themselves. What have we been putting with those numbers so I can use equations? Put x's with them. So, well, in this case, I'm actually going to put a different variable because if I put x with them, it seems like it's going to be equal to that x, which is not. So I'm just going to use y's instead, guys. A, B, C. So A to B to C, that's going to be 2y. C, D will be 3y. D, F, G will be 1y. And A, G will be 4y. What can I do with all those? I'm going to need the value of y here. What can I do with all those? You know every single arc in the circle. You know every single arc. What's it all add up to? 360. Yeah, you can add up all those arcs and set it equal to 360. Now, some of you may be ahead of me and say, well, can I just do 2y plus 3y equals 180? Is that okay? Yeah, because that's a semicircle. AD is a diameter. You could do 4y plus y equals 180. That's a shorter way too. All right, I'm going to take all my arcs now, add them up and set them equal to 360. So I get 10y equals 360. The value of y is 36. Okay, plug it, now go ahead, plug it back in, and we can find all the arc measures. So this is 36. 2y would be 72 degrees. 3y would be 108. And then finally, 4y would be 144. All right, let's find angle x. Is it central? This is going to be a broken record, and you're going to hate it, but I don't care. Is it central? Inscribed? No, neither. So it's got to be a floater angle. What's my rule for floater? 1/2. What arc belongs to angle x? How big is the arc that belongs to angle x? 72 degrees is its measure. Plus, what's its vertical angle's arc measure? 36. There it is. $108, half of 108. Oh boy, 54. Any questions from you guys at home? We are all set. All right, now here it comes now. Here it comes. This is when the entire unit just comes crashing down on one problem. Anything goes. This is just not a floater angle problem anymore. Anything goes. Anything I've shown you, any facts, any theorems on circles, we'll start applying right now. Don't worry about the looks of the diagram. Does it look intimidating? Yes, it does. It's not that bad. And I'm asking you to answer 5 questions. Read the directions carefully so you get every single arc measure you need. Arc AEH, 110. So A to E to H, however you want to label that, is 110 degrees. Arc AG is 80 degrees. And the ratio between AE to EH is 2 to 3. So we've been putting X's with them. So AE will be 2X. EH will be 3X. When you are doing these multi-part questions, I have a piece of advice that I'd appreciate it if you took it. Find all the arcs first. Don't even look at what I'm asking for in parts A through E. If you can find the arc measures, you're going to be in a pretty good spot to solve anything. Try to find all the arc measures first. All right? Don't look at A through E at all. Say to yourself, let me find every arc measure I can. So let me turn this over to you guys. Do you know any arc measures right now that are missing? Can you find any arc measures that are missing?
Just for the sake of this, is AOBC considered a diameter? Do you know that?
It says circle O, and it's going through O, so I would say it's a safe bet mathematically that that's a diameter. Correct. AOB is a diameter. It goes through the center, which is O. All right, help me out. Anybody know an arc measure here? Because I want to find all arc measures before I answer the questions.
You can use the ratio to figure out what arc AE and EH are.
Okay, we can start there. 2x plus 3x equals $110. 5x equals 110. I think that's what, 22? Checking my math there, 22. All right, so x is 22. Plug it back in to find those arc measures. So arc AE will be 2 times 22, 44. And EH will be 22 times 3, 66. You guys all good? Come on, feed me. I need more. You can find more arcs. What are some more missing arcs? How about GB? How about HB? You can find them.
HB is 70.
What? How do you know it's 70?
It's half the circle is 180 and 110 minus is 70.
There you go, 70. Semicircle equals 180. Same thing for GB. Can I say the A to G to B is 180 degrees? So GB will be 100. Watch how easy this is now that I know all the arcs. Find the arcs first. Ready, part A. Oh, it asked me for an arc I already found, 100. I'm just copying it. Part B. Hey, arc EA. I already found it, 44. Look how easy this is. All right, now we got to do some work. Angle EFA. EFA. Guys, ready? Central? Nope. Inscribed. Is it inscribed? Nope. That's a floater angle, isn't it? EFA. So how do I find a floater? 1/2. Somebody help me out from here now. Who's up? Let's roll. 10. Let's go, Atticus. What's the arc that's formed by EFA? What's its measure?
72 degrees.
72. You're getting way ahead of me. I'm just asking for, you're giving me the angle. I don't want the angle yet. I want the arcs that make this up. So EFA. What's the arc measure that makes up EFA?
AE.
Which is how big?
44.
Okay, so 44 plus what's its vertical angles arc measure?
100.
100. There we go. That's where we end up with 72. Okay, everybody good? 72. Hey, I would even plop it in the diagram too. You never know. I might need it. All right, D. Angle FEB. Central? No. Is it inscribed? Yes, it is. FEB. Take a look. E is on the circle. FEB is a chord, or GFE is a chord. So is EB. That's an inscribed angle, ladies and gentlemen. How do I find that inscribed angle? What was my rule to find an inscribed angle? Come on, let's keep the train going. Hayden, how do I find an inscribed angle?
Half of its arc,
What's its arc measure?
44.
FEB. What arc is
100.
100? So I'm going to take half a hundo here. That's going to be 50 degrees. Oh, what?
I did get the same answer, but I didn't realize it was intersected, so I ended up using, because AFE and EFE are supplementary, I ended up getting that, and then I was able to get ABE. So I just got all the degrees of the triangle.
That's fine. Still get 50, right? Yeah, that's fine. If you can't see it, use Yeah, I love using the triangles too. Yep. And then here, yeah, I'm going to get somebody here. OHD. Look at that angle, guys. OHD. Central angle? Nope. Inscribed? No. No. Because, okay, H, I get it. H is on the circle, but the other two sides are not chords. It's a tangent and a radius, the other two. It's a tangent and a radius. The other two sides? Tangent and a radius. There's no arithmetic needed here. What's the theorem say? When those two meet, what's formed?
Right angle.
90 degrees. Just by knowing the theorem, look at that. Just by knowing it. No calculations needed. None. Go ahead, ask any questions. Anything you want here. I know that was your first one. You're going to get exposed to a bunch of those. 2 of them on the quiz, by the way. 2 of these multi-part questions on the quiz. 2 of them. Just find your darn arcs first. All right, can you please do that for me? Don't even look at the question. Look at the arcs. Can you find them or not? Oh, what was that? You need one more because you're hungry? Yeah, you are. Here you go. You got it. One more. Please, please, please read the directions. Don't just look at the diagram and say you're good to go. Here's why I need you to read carefully. Oh, they just plopped this bad boy into the directions. that AP bisects angle BAC. You know, if you just skim that over, do you see that? Maybe, maybe not, and it's pretty important to the problem. And then the angles in the triangle are in a ratio of 4 to 3 to 2. Okay? We've been down this road already. So ACB is 4x. CAB, the angle that's getting bisected, is 3x. And ABC is 2x. All right, let's start. What can you do with those three? If I want to find the value of x, what are you doing with those three angles? Oh, 3. Omni, what are you doing with those three angles?
You're gonna add them all together and then divide 180 by like this.
Yep. So I got 3x, 2x, and 4x. They all add up to 180 because of the three angles in a triangle. I get 8, 5, 4, 9x equals 180. X equals 20. X equals 20. Go ahead, plug them in. So it looks like angle B up there would be 40 degrees. I'm just rewriting it. Angle C is 80 degrees. And then angle BAC would be 60, but it's getting bisected. So hopefully you're comfortable if I put 30 and 30 here. Again, I'm not looking at the questions yet. Can you guys help me find the arc measures? Hey, all those angles in the triangle are also what type of angles for the circle? What do I call 40 degrees? What do I call 80? And each of the 30, those are what type of angles in the circle? Inscribed. So I took half whatever the arc was to get them. So if angle C is 80, what's the measure of arc AB? If angle C is 80, arc AB has to be what measure then? Oh, Omni, up again.
Can you restate the question?
If angle C is 80, what's got to be the measure of arc AB then if that's inscribed? 160. There you go. I double it. The 40, I double. Arc AC is 80. Each of the 30s, I double. BF is 60. FC is 60. Now I know each arc measure. It's going to help so much if you can find all the arcs you can. And if you can find all of them, you might as well just put 100 on your paper. Maybe not, but. All right, angle ABC. Already found it, right? 40. And most of them, now you can just cruise through a lot of these because you already found the value. Arc BF, already found it, 60. The only thing I need your help on is the measure of angle BEP.
How did you get 60
Because each inscribed angle, well, the angle BAC was 60.
Yeah, I got one.
It gets bisected. So that means each angle is 30. Across from it, I double because it's inscribed.
I think I only got
The whole arc BFC is 120, yes.
I only got one.
Okay, BFC is 120 degrees, but each piece is 60.
I think I labeled that as
110 because I thought that I read BEA as an inscribed or yeah, I thought it was central angle.
You good? No central angles here in this diagram. BEP, is it central? Even though I just said there's no central angles in this diagram. Is it inscribed? Nope, it's a floater, isn't it? All right, who's finished in this class off the right way? If it's a floater angle, I'm taking half of what two numbers here added together? BEP. BEP. Finish strong, let's go. Will, finish strong for me, big dog. BEP, half of what arc belongs to BEP?
Arc BF,
60 plus the vertical angles arc.
80.
There you go. So I'm taking half of 60 and 80. Half of 140. That angle is 70 degrees. And before we wrap up, Let's say you just totally blanked on the floater angle rule. Could I have gotten 70 some other way? You're darn right I could have. How many degrees in this triangle AEC? 180, right? You already have 110, so that means that angle's got to be 70, vertical with BEP. Okay? So even if you blank, you can still use the fact that triangles have 180 degrees to try to get through it. Unbelievable, this mathematics. Questions, comments, any concerns? Okay, you got a couple multi-part circle questions tonight on your homework too. Tomorrow, we got to figure out how to find angles like angle P when they're outside the circle. What's the deal there? All right, I will see you guys tomorrow. Behave, make smart decisions. You guys have a great day.
No, you said about it. You said about it.